Hello everyone, myself Dr. TV Nagaraju. I am working as an associate professor in Department of IT, MLR Institute of Technology, Hyderabad. In the series of collection framework, we already completed set interface. The methods are the classes that implements the set interface. Now we are moving to the list interface. This is also one interface that is extended from the collection interface. Now in this session we will move to what are the important methods inside the list interface, how these methods are implemented by different implementation classes. Move on. First to list interface. Before going to list interface, first you need to know what is the difference between their previous, that is set interface. Remember, set interface does not consist of duplicates, but list interface can hold duplicate value. Set interface does not consist of indexing for their elements, but the list interface, the elements are organized based on index. Whatever it is not there in the set interface, that is available inside the list interface. Now, set is implemented by three classes: hash set, linked hash set, and tree set. Similarly, the list interface is implemented by three classes: array list, linked list, and vector. These are the three classes that implements the list interface. Anyway, stack extend from the vector. Remember, stack directly does implement the list interface. Stack extends from the vector. These are the three main classes. What are the most regular methods? Size. What the size method? It returns the number of elements inside the list. If you are using set, inside the set, the methods are almost the same. So, size is empty. Check whether the list consists of any element or not. If the list doesn't consist of any element, the return type is true. That means the list is empty. If the set consists of, or list consists of at least one element, means output is false. That means the set list consists of at least one element. Add means adding an element into the list, removing an element from the list. If you want, you can add multiple elements at a time into the list. If you want, you can remove multiple elements at a time from the list. Whatever we are doing, exactly the same thing. Now, how these methods are implemented? By using array list, linked list, and vector. Move on. First, what is array list? So, it organizes the elements in sequence. We know the concept of array, exactly the same concept. The elements are arranged in a sequential fashion, and it is a non-synchronized class. Again, what is the synchronization? So, you know, in thread classes, two things are there: synchronized and non-synchronized. So, simply move to the threads. You will understand the complete difference between the synchronization and non-synchronized. Here, array is a non-synchronized class. Syntax as usual: class name, object is equal to new class name of. Okay. Now, suppose 1, 2, 3, 4, 5, 6, 7. Like this, the elements are stored in the sequential operation. Now, the thing is, I want to perform one add operation based on index. That means, here one more method, not only this, one more method is also there. Add by index of. Here you are passing value comma index. So, means the value is inserted at specific position. By default, the element is added at the end. If you are writing index, so the element is added at the specified index. Now, what is the advantage? What is the disadvantage? The main problem is, suppose if you want to perform add by index, suppose I want to add an element at 5th position. Assume this is the position. What need to do? All these elements are moves in backward direction. If you want to insert an element at one position, you must and should make that position is free. The elements moves in backward direction. Moves in backward direction. Suppose if you want to remove an element, so all the elements shifted to forward direction. That means the elements are stored in sequential fashion. The space is not available. So you need to remove the space by shifting the elements. You need to create the space by shifting the elements. So that is the main problem. That means more number of times you need to perform shift operation. To overcome this problem, we are using linked list. Overcome that problem, we are using linked list. First I will explain all the problems. So linked list means it organizes the elements in non-sequence. This is the advantage. I think you know the concept of linked list in data structure. It organizes in any fashion. There does not follow. Wherever place is there, place the element. That address is copied into this one. Based on address, we are moving to any position. No need to place. That means we can add or remove in a simple. If you want to add one element, place only that element. Just to copy the link. If you want to remove that element, just update the links. No need to shift all the elements. That is the advantage of linked list. So remember, in collection, the linked list is always a double-ended, double linked list. Means this is the data, address of the next node, address of the previous node. Clear? Now, vector. So vector is also organize the elements in sequence. Then what is the difference? Remember, vector is a synchronized class. Array list is a non-synchronized class. That is the difference. Both are used for storing the elements in a sequential order. But vector synchronized. Array list non-synchronized. Anyway, linked list is non-synchronized with non-sequence. Then no need to do any comparison. Now consider any one example, and that example is implemented by using both array list, linked list and vector. I will show with one example. Write down the example: import java.util.star class demo list. This is demo list. This is my class name. Public static void main okay. Within this one, first thing is you need to create an object for array list. Array list. Which data type you want? You can add integer or string, anything. Suppose string. Some OB is equal to new array list of string data type. Now array list object is created. Now the thing is, you need to do add operation. OB dot add of some XYZ. OB dot add of some PQR. OB dot add of some ABC, and we will add one more OB dot add of some PQR. Observe here, I added duplicate items. If you want, you can use iterator or directly print the value. System dot out dot println OB. Automatically it takes the toString method. By default, either integer objects or string objects take the default toString method, which is used to print all the values related to that object. System.out.println. Now, what I am doing? OB dot size. That is the number of elements inside the list. Now, OB dot remove of ABC. If you want, you can do remove operation. After removal also, again check. After removal, check how many number of elements. Now what I am doing? If you want, you can add multiple elements. OB1 is equal to, now OB1 dot add of any letters. Ignore that one. Some strings. OB1 dot add of clear. I am adding these methods. Now what I am doing? OB dot add all of OB1. I think you got the point. Now OB1 is a list which consists of two elements. Now that list is added to the list OB. That list is added to the list OB. Now print those two values. That is the number of elements and the entire list. Save this one. Demolist.java. Move to the drive. Command prompt. Java C space demolist.java. Some error. Okay, just a small error. Here I forgot semicolon. Now everyone observe the output carefully. Here XYZ PQR ABC PQR. In which order we are placed in the same order, and duplicates are available. Yes, linked list, that is in the list, whether array list or linked list, vector, whatever it is, duplicate are allowed. Total 4 elements. After removing ABC, only 3 elements are there. Here I am adding 2 elements. Now the number of elements becomes 5. Clear? This is array list. Exactly in place of array list, if you return linked list, same thing is happened. If you return vector, same thing is happened. But internally, how they are stored? How they are stored? That is concept. Suppose if you are using in case of array list, if you are using linked list, observe any change in the output? No. This is completely same. Internally, how they are organized, that is different. Even though if you are using vector, again for vector also the same concept. Vector also have the same concept. Now this is the list. This is the list interface. How the list interface is implemented by array list, linked list and vector. In the next session, we will move to stack class, which is extended from vector interface. That's the end of today's session. Thank you.